New chapter, sir.
Hello, Haripriya.
Hi, sir.
Today we'll start new chapter, no? This that is completed. Do you want me to start simple harmonic motion or gravitation?
Anything is fine, sir.
I think
Start
it's
simple harmonic motion.
simple harmonic motion, na? Okay. Diva. अच्छा. Do you know something about simple harmonic motion, Haripriya?
No, sir.
Do you know something about periodic motion and all? See, let me
I've
explain you.
heard of it, but I don't know the exact meaning.
See, the basic one that we already know is a circular motion. That is known as the periodic motion. Why it is known as periodic motion? Because after means if there is a particle, it starts from here, from a point A, it moves like this, circularly. Then again, after a period of time, it reaches again A and then it repeats its motion again. Okay? Because it repeats its motion again after a certain period of time, and every time after a period of time, it repeats the same motion. That's why such kinds of motion which repeats themselves are known as the periodic motion. Okay? And every motion means if when it is doing one cycle, it's moving from A, again it's coming to A. That's known as one cycle. So in this, see, I have defined a periodic motion. Periodic motion is a repetitive motion. Motion which is repeated, which gets repeated after certain interval of time. This is a periodic motion. Now, simple or harmonic motion is a kind of periodic motion or type of periodic motion. The thing is, every periodic motion, every simple harmonic motion is a periodic motion, but every simple harmonic motion is a periodic motion, but every periodic motion, every simple harmonic motion is a periodic motion, but every periodic motion may not be a simple harmonic motion. Okay. How?
Yes.
I'll give you the differentiation between them. In a periodic motion, what I said, we are starting simple harmonic motion today.
Okay, sir.
So in the periodic motion, the what I explained till now, periodic motion and simple harmonic motion. We are starting from periodic motion. Periodic motion is a motion which gets repeated after a certain period of time. That's known as periodic motion. And for a periodic motion, there is a term which is known as time period. Means time period is denoted by T. It is the time after which it repeats its motion. After which motion gets repeated. In this circular case, if you see, it starts from here, covers the angle 2 pi, if it is moving with the angular velocity omega, then the time period, I can easily say this time period t is equal to 2 pi by omega. That's why we say the time period of a circular motion, periodic motion, is 2 pi by omega. And I said every simple harmonic motion is a periodic motion, but every periodic motion may not be a simple harmonic motion. Because I said simple harmonic motion is a type of periodic motion, its time period also will be 2 pi by omega. Okay. Now, but the thing is, we can represent every simple harmonic motion in this kind of circular periodic motion. That's the beauty. Okay. Now, what is the thing which differentiates between the simple harmonic motion and the periodic motion? Simple harmonic motion is a periodic motion, first thing. Second thing which differentiate these two is in this motion there is always a force acting towards the mean position. See, in a periodic motion, it's not necessary that there will be a force which will always be acting towards the mean position. It's not necessary. But in simple harmonic motion, it is necessary that a force should be acting which is always directed towards the mean position. Right? Understood?
They're like a pendulum.
Like a pendulum. Like a pendulum also you can say. In the pendulum is also a case of simple harmonic motion in which you will see there is always a force which is acting towards the mean position. Mean position is a vertical position. The force brings it back to its mean position always. So there is always a force. That's very good example. Simple pendulum is a simple harmonic motion example. Now, how do we define things? Means when we solve problems on this, there is a major portion on the basic formulas. That basic formulas I'll tell you. Because I said every simple harmonic motion can be represented as a periodic motion. So I can represent any simple harmonic motion in the form of circular motion. See, I'll show you how. Suppose I have taken a point. This is a point P starting from here. Now, if you look it from this side, either from the right or from the left, how its motion looks like, it's moving up, first moving up again here, then it's reaching to the position Q, then again it's moving down, again coming here, and then again moving down, again reaching to R, then again reaching to P. Okay, from the side if you see, this motion will look like it's doing a motion like this. This is the position P. It has moved up to the position Q, then again came back to the position R, then again came to position P. Right now, this is how actually when we solve the problems of simple harmonic motion, now we show simple harmonic motion in this way. But you have to visualize it. The body is starting from P, moving up, then moving to the point Q, then moving down, again moving down, crossing the point P, moving down again, and then from R it's coming up again, and then it's stopping. This is one cycle. Then again the cycle gets repeated. Clear?
Yes, sir.
Now, since I said every simple harmonic, this is a case of simple harmonic motion. Simple harmonic motion can be represented in a periodic motion. So we'll do the calculation according to the simple harmonic motion. according to this periodic motion only. Let's say the position of a point P, the point which has started from P, this is A somewhere here. So in the time t, if it is moving with the angular velocity omega, this theta should be equal to omega into time t. So if I said the radius is a, I can just write this value of y, means the displacement, means if I compare this with this is p is the mean position. I'll explain you about the mean position also. So I can write this is y, so I can easily write here this y is equal to what? A sine theta or a sine omega t, right? So that means the displacement in an SHM, in a body doing SHM, I can just write that as y is equal to a sine omega t, where omega is the angular frequency, t is the time period, and a is the amplitude. How I'll show the amplitude here? Because you know this distance is a, radius, so obviously this distance should be a, means starting from point P, the maximum it moves up is a, maximum it moves down is again a. Okay, so how we have learned here, if we are taking the angle in this way, it is a sine omega t. If we are taking an angle from the top, it will become a cos omega t, sine of 90 minus omega t, not a problem. So what I understood from here, any motion in SHM I can write as y is equal to, if I'm moving along the y-axis, I can write y is equal to a sine omega t, or y is equal to a cos omega t. Understood this one? Clear? Now taking this thing, I'll now try to analyze the simple harmonic motion totally. This is a simple harmonic motion. This is point O, this is A, this is B, this is X. This SHM is taking place in the X direction. So I can write its equation as X is equal to a sine omega t, or if you want you can take a cos omega t also, where this a distance is this. Clear? This is first thing. Now if someone wants to ask you about the velocity, how you'll do? P is equal to dx by dt. Okay na? This way you can find out the velocity. It will be a omega cos omega t. Correct?
Yes.
If you want, you can write it as a omega root over 1 minus sine square omega t. For this I can write as a omega root over cos square omega t, and cos square omega t I can write as 1 minus sine square omega t. So omega will keep outside. It will be a square minus a sine omega t whole square. So this velocity expression has become omega root over a square minus, but a sine omega t was displacement, minus x square. So see, whenever you are solving questions, x is displacement in simple harmonic motion can be taken as a sine omega t, and if they ask you about the velocity you can use to solve the formula, to solve the question you can either use v is equal to a omega cos omega t, or for the convenience you can use this formula also, omega root over a square minus x square, where x represents the displacement, omega is the angular frequency, a is the amplitude.
So we will still get the same answer whether we use a sine omega t or a cos omega t.
Now you'll get the same answer. See, if you can try it out. See, if I take x is equal to a cos omega t, if you take x is equal to a cos omega t, you'll get velocity as dx by dt, which will be minus a omega sine omega t. Okay, now this will be minus a omega root over 1 minus cos square omega t. You can take omega outside. This is a square minus a cos omega t whole square. So you can write like this, omega root over a square minus x square. The formula you're going to get is same. Direction is different, but the quantity will be always same. Results won't change. Whatever is there in your notebook, you can use that one. If in your coaching they have started with using x is equal to a cos omega t, you can use that also. If x is equal to a sin omega t is there, you can use this also. Not a problem. Both ways you can represent. Okay, clear?
Yes, sir.
Now if we try to further analyze it, can you tell me what will be the Vmax? What will be the maximum value of the velocity and the minimum value of the velocity using this formula? Or either analyze using a omega cos omega t, or analyze using omega root over a square minus x square, whatever suits you. It's very easy. If you want to get the velocity of maximum, how you want to analyze? Using a omega cos omega t. If by using a omega cos omega t we use, velocity is this. What is the maximum and minimum value of cos omega t? It lies between -1 and 1 now.
Yes, sir.
So the value of a omega, maximum and minimum value of a omega cos omega t velocity will be what? Minus a omega and plus a omega. So the maximum velocity, but minus a omega represents the direction only. Quantity wise, the Vmax is plus or minus a omega only. This is the maximum value. Now, if you want to talk about the minimum velocity, when it will be minimum, when x is equal to this, the minimum value of this cos omega t is 0. We are not, see, I'm not taking the minus sign, because minus sign represents only the direction in the case of velocity. Cos omega t minimum value is 0. So the V minimum will be 0. Now, if you want to further analyze at what point it will be maximum, at what point it will be minimum, you see where the cos omega t becomes 1 at t is equal to 0. When omega t is equal to 0, V becomes a omega, na? Because cos omega t has to be 1. That is at t is equal to 0. Meaning, when it starts from O, it will have the maximum velocity. It starts from O, moves to this A, again it comes back, it will have the maximum velocity either in this direction, or when it is moving back, coming to A moving back, it has the maximum velocity Vmax is equal to a omega, or it's going to B coming back, it has a maximum velocity omega. That's why two directions you are getting plus or minus a omega. And I did not say you about tell anything about the mean position now. Mean position is the position where net force is 0. Equilibrium position. So in this case, because no force is acting, the mean position becomes O. Okay. So at the mean position, velocity is maximum at x is equal to 0. If you want, you can analyze from this also, this formula. Here at x is equal to 0, you get V as plus or minus a omega. And if you want V minimum will be 0 at x is equal to plus or minus a. Means here at the maximum amplitude position, its velocity will be 0. Here at B, velocity will be 0. Why? Because when physically analyzing, the particle starts from O, moves right, and when it is changing its direction, it has to come momentarily at stop, at A. Momentarily, it should stop at A, right? Again, when it is moving back at origin, it will have the maximum velocity. When it will move again to the back B, it will momentarily stop at B. So there also velocity has to be 0. So you understood now? Where in the simple harmonic motion the velocity will be maximum and where it will be minimum, and what its value is.
Yes.
Okay.
Yes.
Okay, now velocity we have found. Now acceleration. Acha, let's calculate about the energies also. See, you only know two kinds of energies. One is kinetic energy. Kinetic energy is easy to calculate. Kinetic energy is half mv square. But since we know in simple harmonic motion v is omega root over a square minus x square, so we'll do its square. So it will become half m omega square into a square minus x square. This is kinetic energy, or if you want to write it in other terms, it will be half m a square omega square cos square omega t. Like that also you can write. Both are okay. Okay. Now coming to the potential energy. Potential energy, for that I will have to explain you about the acceleration. Let me explain you about the force and acceleration also. Acceleration, if you want to find v is equal to, we know, because v is equal to a omega cos omega t. So acceleration will be dv by dt. It will be minus a omega square sin omega t. This is acceleration. This value you should know. Or because you know a is equal to minus omega square, a sin omega t is actually your displacement we have earlier assumed. So you can write A is equal to minus omega square x. This is the important value. What you can analyze from here, that whenever displacement is in the direction, actually the acceleration is actually opposite to the direction of displacement here. Means when it's moving towards right, its acceleration is towards left, minus omega square x. And okay, but since you know this is acceleration, so the force will be what? F is equal to ma. So the force is also in the same direction. Force is equal to ma, so it will be minus m omega square x. So from here we have got a result that you know, because I said earlier in a simple harmonic motion always the force acts towards the center. That's why here we have derived it actually by using acceleration, that force is always acting towards the center. If it goes right, x is positive, f will be minus m omega square x, towards left, towards mean. If it is going left, x is negative, so f is equal to m minus m omega square minus x. So force will be towards right. So that's why the force is always towards the mean position. Force is always towards the mean position. Understood? And the value of force is this, minus m omega square x. Now, if you talk about A max, where will be maximum acceleration? Where displacement is maximum, minus omega square A, because x maximum is A only. Also, at x is equal to minus A, it will be plus omega square A at x is equal to, which occurs at the extreme positions. You're getting it or not? Haripriya, Diva?
I got a little bit confused
Where?
about the direction part.
Direction of what? Acceleration?
Sir, the part of
Where?
so it's not exactly what point. It, I understood everything, but at the same time it's confusing.
Which part? From which part you are feeling it confused?
The kinetic energy.
Kinetic energy, na? Actually, see, I thought I will cover the energies first, but when I came to the potential energy, na, I realized I need to explain you about the acceleration and force, because after that only I'll be able to explain you about potential energy. Kinetic energy should be okay, but after kinetic energy, for potential energy, we needed to derive the force and acceleration. That's why I moved on to this part. Okay, till kinetic energy part is okay, na? It's half mv square only.
It's just substituting v square.
Just substituting v square. See, why after potential, when we are doing about potential energy, I wanted to show you F is equal to minus m omega square x. That's why I derived that acceleration and force. Now here, potential energy is, you know, through work energy theorem, potential energy is nothing but work done stored as energy. F dot dx stored as energy, TW. Yes, na? Potential energy is negative of work done. So if you integrate 0 to x, minus m omega square x square by 2. So the potential energy is m omega square x square by 2. Or if you want to easily understand this formula is actually important. This formula you know already. Work is potential energy is the negative of work done when it's moving so slow. If you are getting confused, you can compare it with minus kx. You know that Hooke's law spring force na? In spring force is F is equal to minus kx. What is the potential energy stored? E is equal to half kx square na? Here k is m omega square. So put the value, you'll get k half m omega square x square. Like that also you can see. Okay. Which one is easier for you that you can use? But potential energy is negative of work done. This concept is important. These formulas only I wanted to show you actually. Now I'll make you solve some question. You'll feel better. One more thing. Total energy is always constant. Total energy is kinetic energy plus potential energy. Kinetic energy is half m omega square into a square minus x square. And potential energy is half m omega square x square. If you sum them up, you'll always get one value only, which is a constant. So the total energy in simple harmonic motion always remains a constant. Means how the things are changing. When in a simple harmonic motion, when a body moves, sometimes its kinetic energy gets increased, then its potential energy will be decreased. And when its kinetic energy gets decreased, its potential energy will increase. But the sum of kinetic and potential energy always remains constant. Okay, now let me make you solve some question, then things will be clear to you. Take this question. Try to understand this question first. If you have any doubt, if you are not able to solve, just tell me, I'll solve it. Do you want me to solve? Haripriya Diva? Or you are able to do it?
So given
Hint?
example, yeah.
See. Let me solve this question first. Once I solve it, now you'll get an idea how to solve questions of this type. First, let's understand the question. Simple harmonic oscillator. Simple harmonic oscillator means simple harmonic motion. Has an amplitude A. Amplitude is A. Okay. Time period is 6 pi. Time period means we can find out the omega because t is equal to 2 pi by omega is there. So t is 6 pi. 6 pi is equal to 2 pi by omega. So omega angular velocity will be 2 pi by 6 pi. So it will be 1 by 3. Omega we have found. Assuming the oscillator starts from its mean position, the oscillator starts from mean position. Is starting from x is equal to 0. Now time required by it to travel from x is equal to a, and this is x is equal to a, x is equal to root 3 a by 2 will be this. We know x is equal to a sine omega t. Now omega we have found. When x is equal to a, sine t by 3 is there. Sine t by 3 is equal to 1. T by 3 is pi by 2. So t is equal to 3 pi by 2. This is first time. The time when it was at x is equal to a is 3 pi by 2. Now similarly, in a case 2, when it is at root 3 by 2a, it will be a sine omega t2, which will be root 3 by 2 is equal to sine of t2 by 3.
It
Sine
will be
60.
sine 60.
Pi by 3. t2 by 3. t2 is equal to pi only.
Mm.
So time difference is t1 minus t2, which is 3 pi by 2 minus pi, which is pi by 2. So x is equal to
Yeah.
2.
Yes.
Easy? Solved it? This is how we solve it. It was easy now?
Yes.
Just the application. In the similar way, try to solve this one. These are not difficult ones. These are easy questions only. If you want to see some formulas, if you want to look at some formulas which I have just told, I'll scroll it up. Try solving this. What happened? You could not solve this?
No, sir.
Actually, you will be able to solve it once you get to know these formulas. You will have to just memorize them once. You have to understand it. It's just the application. See, the velocity of particle executing SHM is given by this. You already know. Velocity in SHM is given by omega root over a square minus x square, right? If you compare this, given expression v square is equal to 1 by 4 into 50 minus x square is there. So v will be what? 1 by 2 root over 50 minus x square. That means what? Comparing this with this, you will get omega is equal to half, a square is equal to 50. Now, we are not worried about this because time period they have given it is x by 7. We have to get the value of x, but we know t is equal to 2 pi by omega, and omega value we already know 1 by 2, so it will be 2 pi by 1 by 2, it is 4 pi, and we know pi is equal to 22 by 7, it's given, so 4 into 22 by 7, so it will be 88 by 7. So the value of x you should get is 88. This should be your answer. You had to compare only the given expression with this one. V is equal to omega root over x square minus x square. But the problem is, I think you are not able to. These formulas became too much for you. Yes, do you want me to give some easy question? Much easier question?
So not too easy, maybe. Like me, like a little bit.
Little bit better, no?
Um,
Okay. Wait. See, I'll give you. Try this one. How do you see this question? How was it? Was tough or easy?
I was doing something else. So, I didn't compare the equation. I was thinking we had to solve it.
Hmm. What about you, Haripriya?
Sir, I substituted every formula in it.
You substituted every every formula. Haripriya, at what time you sleep?
Sir, usually 11:30 I'll be asleep.
11:30, na? It'll take some time. This part is important. Actually, every time they give questions on these formulas only. I try to see this one. I can see this here. You must use the velocity formula.
Sir, option C.
Correct. Okay, this is correct. Option C is correct. Achha, do you know something about phase? What is a phase? See, this y is equal to a sine omega t is there, no? The angle inside the sine is known as phase. Okay. Sometimes in question they give phase. Achha, try solving this one. These questions are not difficult. I'll do one thing. I'll send you a list of questions which are not difficult. They're easy only. So that once you solve those questions now, you'll understand how to apply these formulas. After class, I'll send you the group. Try solving it quickly, then we'll end the class. Just application of formula. What happened? This should be easy. See, v is equal to omega root over a square minus x square. That formula only you have to apply. Angular frequency omega is 2. Omega is 2. Velocity is 20 mm. Acha, the velocity they want.
Given frequency.
Frequency is given, and x is equal to 20 mm, amplitude is 60 mm. You have to just
Sir,
put
omega is equal to 2 pi into frequency, right?
no. 2 pi f, that frequency is different. See, whenever this unit is given radian per second, whenever radian per second is given something, it's omega only. And whenever frequency is given as hertz or second inverse, that is your 2 pi f. Then you have to apply 2 pi f, because
Okay.
that frequency is 1 by time period. Its unit is second inverse or hertz. There you have to do, because you have to find out this omega. Omega is 2 pi by t. 1 by t is f. That's why you use 2 pi f. Okay? That frequency is different, but here this is radian per second, so the value of omega is given.
The answer is C.
113.
Yes, sir.
Easy na? 60 square minus 20 square. Do it. You'll get it. 113 mm per second. Okay, let's end it. Now, you just try to see these formulas. Then we'll be solving a tougher question in the next class. Bye bye.
Amazing.